Students, so welcome back to my video lectures on the third chapter of 11th standard, which was that we were talking about that is classification of elements and periodicity in properties, isn't it? So we were talking about we were solving the multiple choice questions on this chapter, chapter 3 of 11th standard, that is classification of elements and periodicity in properties. So students, we have solved so many questions. I think we have solved up to around 60 questions. Let us check out which was our last question. The last question is, see this, I think this was my last question, isn't it? I told you what was the answer for this. The answer for this is option C. M2 plus giving rise to M3 plus electron. Yes students, so now let us move on to the next question. The next question is, which of the following oxides is neutral in nature? I think I have given a clear-cut idea about this type of questions. We will come across the same type of questions in S block elements as well as in P block elements, P block of both 11th standard as well as 12th standard. So you should have a clear-cut idea about this type of question, which type of oxides is neutral in nature. I told you oxides may be acidic, oxides might be basic, or oxides might be neutral. I have told you there is only one oxide which is neutral, which is that carbon monoxide. Carbon monoxide is a neutral oxide. It's a neutral oxide. Whereas, and even the oxides can also be amphoteric in nature. The oxides can also be amphoteric. What do you mean by amphoteric? That which behaves both as an acid as well as a base. So we can have acidic oxides, basic oxides, amphoteric oxides and neutral oxide. The oxide that is neutral is carbon monoxide. Remember, oxides which are formed from non-metals, non-metallic oxides are usually acidic in nature, whereas metallic oxides are what? Basic in nature. Whereas the oxides of tin, lead, aluminium, zinc, all these are what? Amphoteric in nature. Amphoteric in, they're amphoteric in nature. So non-metal oxides are acidic, metallic oxides are basic. The oxides of tin, lead, aluminium, zinc are amphoteric, whereas carbon monoxide is neutral. So which of the following oxides is neutral in nature? So strontium oxide, what is it? It's a metallic oxide. So it is basically basic in nature. It's a basic oxide. Aluminium oxide, I told you the oxides of aluminium are what? Amphoteric in nature. Yes, it is amphoteric in nature. That's exactly correct. Carbon dioxide, it's an oxide of non-metal. Carbon is a non-metal. It is acidic in nature. Correct? How about carbon monoxide? I told you carbon monoxide is what? Neutral. Carbon monoxide is neutral. Are you getting my point? So strontium oxide is basic oxide, aluminium oxide is amphoteric, carbon monoxide is acidic, carbon monoxide is neutral, carbon dioxide is acidic. So the question is, which of the following oxides is neutral in nature? So which one is neutral? It is option D. So carbon monoxide is neutral in nature. Hope you have understood? Yes. Now let us move on to the next question. Yes. What is the next question? Which of the following sets of oxides are amphoteric in nature? Again the same type of questions. Which of the following sets of oxides is amphoteric in nature? Which are those amphoteric oxides? Amphoteric oxides. Yeah, can you please tell me which are the different amphoteric oxides? Amphoteric oxides, yeah, okay, yes, tin, lead, aluminium, zinc, correct? So we have aluminium oxide, arsenic oxide and zinc oxide. So aluminium oxide and zinc oxides are obviously what? Obviously they are, yes, amphoteric oxides. Yeah, therefore I can just clearly say that aluminium oxide, arsenic oxide and zinc oxides are amphoteric in nature. Okay, aluminium oxide, arsenic oxide and zinc oxides are amphoteric in nature. How about carbon monoxide, nitric oxide? Okay, yeah, nitrous oxide, they are neutral oxides. Okay, carbon monoxide, okay, nitric oxide, nitrous oxide are neutral oxides. Whereas sulfur dioxide, Cl2O7, these are what? Acidic oxides. They are acidic oxides. Acidic oxide. These are what? Neutral oxides. Okay, these are, okay, amphoteric oxides. Whereas sodium oxide, okay, sodium oxide, magnesium oxide and barium oxide are, okay, they are oxides of metal. Oxides, sodium, magnesium and barium. Sodium, magnesium and barium are metals. So metallic oxides, we know metallic oxides are basic in nature. They are basic oxides. Sulfur and chlorine are non-metals. Non-metallic oxides are acidic oxides. Is it correct? Carbon monoxide, I have told you, carbon monoxide, nitric oxide, nitrous oxides are neutral in nature. Whereas aluminium oxide, arsenic oxide and zinc oxide are amphoteric oxides. Yeah, so which of the following sets of oxides is amphoteric in nature? It is option B. Understood? Simple? Yes, that's great. Okay, yeah, shall we go with the next question? Yes. Okay, what is the next question? What is the decreasing order of basicity of hydroxides of the alkaline earth metals? What is the decreasing order of basicity of hydroxide? Decreasing order of basicity of hydroxides of alkaline earth metals. See students, actually this question has to be discussed under S block elements. That is, we have a separate chapter called as S block elements in 11th standard. We could discuss that chapter, no, this type of question in S block elements, but no problem. Let us finish off here itself. Okay, what is the decreasing order of basicity of hydroxides of alkaline earth metals? So we have beryllium hydroxide, magnesium hydroxide, strontium hydroxide and barium hydroxide. By the way students, what is a base? What is a base? Okay, so according to Lewis acid base theory, base is any substance which donates electron pairs. That means base is electron pair donors. Okay, bases are what? Electron pair donors. Are you getting my point? Okay, yes. So according to Lewis acid base theory, okay, base is any substance which donate pair of electrons, not just one electron, it donates pair of electrons. So electron pair donors are called as bases. Now if any substance has to donate a pair of electrons, or if any substance has to donate electrons, okay, then it should have low ionization enthalpy, isn't it? Okay, if I have to donate my electrons, my ionization enthalpy should be less. Do you agree with my point? Yes. So only those substances which have low ionization enthalpy, okay, low ionization enthalpy, lower the ionization enthalpy, okay, yes, lower the ionization enthalpy, easy to donate, okay, pair of electrons, easy to donate what? Pair of electrons, hence stronger will be the base. hence it's going to be a stronger base. Is that correct? Yes. Okay, so if I can donate my electron pairs, I'm going to be a base. If I donate my electron pairs easily, then I'm going to be a strong base. If I cannot donate my electron pairs easily, then I'm going to be a weak base. I hope you understood. Okay, yes. So if I have to donate my electron pairs, I should have low ionization enthalpy. Lower the ionization enthalpy, easily I can donate electron pairs. If I donate my electron pairs very easily, then I'm going to be a strong base. Are you getting my point? Okay, please understand this sentence. Understand the sentence carefully. Okay, so according to Lewis acid base theory, base is any substance which donate electron pair. Electron pair donors are called as Lewis bases. Okay, so if I have to donate, if any species has to donate electron pairs, okay, then it should have low ionization enthalpy. So lower the ionization enthalpy, easier will be the donation of electrons. Easier the donation of electrons, stronger will be the base. Now he is talking about alkaline earth metals. See how one chapter is interlinked to other chapter. It is basically, okay, a question from S block elements, but okay, the answer to this question can be answered. Okay, this question can be answered by the concept of classification of elements and periodicity in properties. That is, okay, we can explain, okay, this question on the basis of ionization enthalpy. So lower the ionization enthalpy, easier will be the donation of electrons. Easier the donation of electrons, stronger will be the acid. Stronger is going to be the acid. Understood? Okay, now we have different alkaline earth metals. Which are those different alkaline earth metals that are given here? Okay, we have been given with beryllium, magnesium, strontium and barium, isn't it? Strontium and barium. Hope you can see this. Now we know, students, down the group, ionization enthalpy increases, isn't it? Okay, we know that down the group ionization enthalpy, down the group ionization enthalpy decreases. Do you agree with my point? Down the group ionization enthalpy decreases. When the ionization enthalpy decreases, okay, that means, what do you mean by ionization enthalpy decreases? Lower the ionization enthalpy, easy to donate the electrons. Okay, if it is easy to donate the electrons, then the metal oxide or the metal hydroxide, it's going to be a strong base. Okay, therefore, can I say that, okay, down the group ionization enthalpy decreases. That means the donation of electrons becomes easier. When the donation of electrons becomes easier, the basic character increases. Do you agree? The basic character increases. Therefore, can I say that down the group basic character increases. It might be the basic character of oxides or the basic character of hydroxides. Both oxides and hydroxides of alkali metals and alkaline earth metals are strong bases. Oxides and hydroxides. Okay, I'll write it here. Oxides and hydroxides of alkali metals, okay, and alkaline earth metals, okay, are basic in nature. Understand that point. Okay, and the basic character of oxides and hydroxides, basic character increases down the group. Increases what? Down the group. Why it increases down the group? Because ionization enthalpy decreases down the group. Ionization enthalpy decreases down the group. Okay, I hope you have understood about these things. Okay, are we clear? So down the group, the basic character increases. Okay, so which is a strong base among these hydroxides? They have given hydroxides. Oxides and hydroxides are both strong bases. Okay, so down the group, the basic character increases. So which hydroxide is a strong base? I can write it here. Which hydroxide is a strong base? Yes, come on. So we down the group, we have barium hydroxide, magnesium hydroxide, strontium hydroxide, and beryllium hydroxide, magnesium hydroxide, strontium hydroxide, and barium hydroxide. So down the group, basic character increases. Down the group, basic character increases. Therefore, which is a strong base? Yeah, barium hydroxide is a strong base than strontium hydroxide, which is a strong base than magnesium hydroxide, which is a strong base than beryllium hydroxide. Okay, this is the order of basicity of hydroxides as well as oxides. Okay, even the oxides, barium oxide is a strong base than strontium oxide, which is a strong base than magnesium oxide, which is a strong base than beryllium oxide. So what is the correct answer for this? Okay, this order holds good for both hydroxides as well as oxides. So what is the correct answer? The correct answer is, yeah, barium hydroxide is a strong base than strontium hydroxide. Strontium hydroxide is a strong base than magnesium hydroxide, which is a strong base than beryllium hydroxide. Yes, therefore the correct answer is option C. Option C. Okay, simple. That's great. Okay. We'll move on to the next question, students. Okay, what's the next question? Well, it seems to have a big question. Okay, but it's a simple question which is based on Mendeleev's periodic table. What were the main demerits of Mendeleev's periodic table? What were the main demerits of Mendeleev's periodic table? Hydrogen has been placed in group 1, though it resembled group 2 as well, group 7 as well. Position of some elements were not justified. Isotopes were not given separate places. Lanthanides and actinides were not included in the table. Lanthanides and actinides were not included in the table. So we have got four different questions. Okay, look at the different demerits of Mendeleev's periodic table. Hydrogen has been placed in group 1, though it resembled group 7 as well. Position of some elements was not justified. Isotopes were not given separate places. Lanthanides and actinides were not included in the table. Lanthanides and actinides were not included in the table. So we will go back to the Mendeleev's periodic table. I have shown that I have a Mendeleev's periodic table. What is that? Yes. Yes. So this is Mendeleev's periodic table. Let us discuss the demerits of Mendeleev's periodic table. Demerits of Mendeleev's periodic table. Okay, demerits of Mendeleev's periodic table. Look at the demerits of Mendeleev's periodic table, students. Okay. Well, okay, see, Mendeleev's periodic table, I have told you in the previous video that in Mendeleev's periodic table, okay, elements are arranged in the increasing order of atomic mass. Elements are arranged in the increasing order of atomic mass, isn't it? Okay, so in Mendeleev's periodic table, elements are arranged in the increasing. Hope you can just see this. Okay, hydrogen atomic mass is 1.008. Next, lithium 9.639, beryllium 6.939, beryllium 9.012, boron 10.81, carbon 12.011, nitrogen 14.007, oxygen 15.999. Like this, elements are arranged in different horizontal rows and vertical columns. Okay, elements are arranged in different horizontal rows and vertical columns in the increasing order of atomic mass or increasing order of atomic weight. Okay, so in Mendeleev's periodic table we can find only how many groups? 1, 2, 3, 4, 5, 6, 7, 8. Okay, we can find 8 groups in Mendeleev's periodic table total. But our modern periodic table, that is long form of periodic table, has 18 groups. But in Mendeleev's periodic table, see this? Okay, this is our modern periodic table. Our modern periodic table has 18 groups. 18 groups from group 1 to group 18. Total 18 groups in the modern periodic table, that is long form of periodic table. Whereas in Mendeleev's periodic table there are only 8 groups: group 1, group 2, group 3, group 4, group 5, group 6, group 7 and group 8. There are only 8 groups in the periodic table, Mendeleev's periodic table. And how are the elements arranged? Elements are arranged in the increasing order of atomic mass. See, when the elements are arranged in the increasing order of atomic mass, okay, look at hydrogen. Hydrogen belongs to group 1. When in the Mendeleev's periodic table, hydrogen is placed in group 1. But Mendeleev tells us that elements belonging to the same group will have same physical properties as well as chemical properties. Mendeleev has clearly told that elements belonging to the same group will have same physical property as well as same chemical properties. That means if hydrogen is placed in group 1, then all these metals should have same physical properties and same chemical properties. Yes, no doubt. These elements have same physical properties and chemical properties. But hydrogen also has some of the properties which resembles group 7. That means halogen family: fluorine, chlorine, bromine, iodine. Okay, are you all able to understand my point? So hydrogen resembles group 1 elements as well as group 7 elements, but he has placed hydrogen in group 1. Okay, but no explanation was given why hydrogen is placed exclusively in group 1. Okay, why hydrogen is placed exclusively in group 1? This is one of the demerits of Mendeleev's periodic table. Okay, what is the demerit of Mendeleev's periodic table? Position of hydrogen is uncertain. Position of hydrogen is uncertain. This is one of the demerit of Mendeleev's periodic table. Okay, well, he is arranging the elements in the increasing order of atomic mass: hydrogen, lithium. Look at here, you can just observe the numbers here. Okay, there is increasing order of atomic mass, isn't it? Okay, if the elements are arranged in the increasing order of atomic mass, why not isotopes? Because isotopes will also have different atomic mass, isn't it? What are the different isotopes of hydrogen? Protium, deuterium and tritium. Atomic mass of hydrogen is, so protium is 1, deuterium is 2, tritium is 3. Okay, so if different isotopes have different atomic masses, then they would also have been placed in the Mendeleev's periodic table. But Mendeleev did not place any isotopes with different atomic masses in his periodic table. That means that is also one of the demerit of Mendeleev's periodic table. Okay, so what is the other demerit of Mendeleev's periodic table? Yes, isotopes were not placed in Mendeleev's periodic table. This is another drawback of Mendeleev's periodic table. Now, I am telling you repeatedly that elements are arranged in the increasing order of what? Atomic mass. Elements are arranged in the increasing order of atomic mass. So if elements are arranged in the increasing order of atomic mass strictly, look at these two elements. We have tellurium 127.60 and iodine 126.90. Elements are arranged in the increasing order. Look here, lithium 9.639, beryllium 9, okay, boron 10.81, carbon 12, nitrogen 14, oxygen 15.999, fluorine 18.9998. Okay, so elements are arranged in the increasing order of atomic mass. But observe tellurium and iodine. Tellurium, atomic mass of tellurium is 127.60, whereas atomic mass of iodine is 126.90. That means iodine has less atomic mass than tellurium. Therefore, okay, in the periodic table, first iodine should come and then tellurium. But look at Mendeleev's periodic table. First comes tellurium and then iodine is placed. That means position of certain elements is not justified in the periodic table. The best example is tellurium and iodine. Okay, so if the elements are strictly arranged in the increasing order of atomic mass, first we would have observed iodine and then tellurium. But in Mendeleev's periodic table, actually tellurium is placed first and then iodine. So position of certain elements is not justified. Yeah. The next, okay, demerits of Mendeleev's periodic table is position of certain elements is not justified. Okay, position of certain elements is not justified. The best example is, okay, iodine and tellurium. Actually, iodine should come under 6th group and tellurium should come under 7th group, but iodine is placed under 7th group, okay, whereas tellurium is placed in 6th group. Why is this? No proper justification was given. And you can observe this entire periodic table. Do you find any, okay, noble gases here? We have helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, okay, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, okay, potassium, calcium, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc, like that. Okay, can you find any noble gases? Can you find any noble gases in this periodic table? No, there is no noble gases at all. That means, okay, noble gases were not given any place in Mendeleev's periodic table. Okay, noble gases were placed separately in the 0th group of Mendeleev's periodic table. Why noble gases were placed separately in the Mendeleev's periodic table? No proper explanation was given. That is also one of the demerit of Mendeleev's periodic table. Understood? Okay, what's the other demerit of Mendeleev's periodic table? Yeah, noble gases were not considered, okay, in Mendeleev's periodic table. So these are the different demerits of Mendeleev's periodic table. Now let us go back to the same question and let us see the answer for it. Okay, yes, what was the question? Yes, I think this is the question. So what are the main demerits of Mendeleev's periodic table? Hydrogen has been placed in group 1, though it resembled group 7 as well. Yes, so that means position of hydrogen is uncertain. Yeah, it is one of the demerit. Next, position of some elements was not justified. Yeah, of course, the best example is iodine and tellurium. Okay, it is another demerit of Mendeleev's periodic table. Isotopes were not given separate places. Yeah, okay, isotopes were not placed in Mendeleev's periodic table. That is another drawback. Lanthanides and actinides were not considered, were not included in the table. Okay, do we have lanthanides and actinides in the Mendeleev's periodic table? Okay, lanthanides and actinides. I think we don't have lanthanides. Lanthanides means the 14 elements from lanthanum. Okay, look at here. Okay, just observe here, these elements are called as lanthanides. Okay, from lanthanum to lutetium, from actinium to lawrencium. These 14 elements, the 14 elements after lanthanum and the 14 elements after actinium are called as what? Lanthanides and actinides. Just let us search, do we have lanthanides and actinides in Mendeleev's periodic table? Do you find any lanthanides? Yeah, we have niobium. Yeah, look here, lanthanum is a lanthanoid. Okay, lanthanum, we have niobium. Yes, we have osmium. Okay, so that means there are lanthanides and actinides in Mendeleev's periodic table, isn't it? Okay, look here, lanthanum. Okay, niobium. Do you find niobium? Yes, anywhere? Okay, no. Niobium comes somewhere, yeah, here in this. Okay, it's a D block element, but lanthanum is a lanthanoid. Okay, so lanthanoids are placed in Mendeleev's periodic table. Okay, but not all the lanthanoids are placed in Mendeleev's periodic table. Do you find any lanthanoids? Uranium, thorium, plutonium? No lanthanoids in the Mendeleev's periodic table, isn't it? There are no lanthanoids in the, okay, as well as there are no actinoids in the Mendeleev's periodic table. That means it is also going to be the some of the demerits of Mendeleev's periodic table. Okay, yes. So there are no lanthanoids and actinoids in the Mendeleev's periodic table. That is also another drawback of Mendeleev's periodic table. Got it? Okay. Yes. So the fourth. Okay. What is it? Which question is it? Yeah. Lanthanides and actinides were not included in the table. So first one is a demerit, second one is a demerit, third one is a demerit, fourth one is also the demerit of Mendeleev's periodic table. So what is the correct answer? It is option B. All are the demerits of Mendeleev's periodic table. Mendeleev's periodic table. Okay, hope you have understood. Yes. Now let us go with the next question. Yes, an element with atomic number 79. An element has atomic number 79. Predict the group and the period in which the element is placed. An element has atomic number 79. Predict the group and the period in which the element is placed. There are so many ways which I can solve this problem, students. There are so many ways. One simple way is to just write the electronic configuration of the element with atomic number 79. If you just simply write the electronic configuration, then you can clearly tell to which group, to which period it will belong. Okay, so we shall just write the electronic configuration of this element with atomic number 79. Okay, I hope you know, okay, the energy level diagram. What is it? 1s, 2s, 2p, yes, 3s, 3p, 3d, 4s, 4p, 4d, 4f, 5s, 5p, 5d, 5f, 6s, 6p, 6d, 6f, 7s, 7p, 7d, 7f. Okay, and one more thing. Okay, group number. Group number is usually equal to what? Okay, group number is usually equal to number of valence electrons. Number of valence electrons. Group number is usually equal to number of valence electrons and period number. Okay, period number is usually equal to, okay, n value, principal quantum number value for, okay, the valency shell. For the valency shell. Are you getting it? Okay. Yes. Simple. Group number is equal to number of valence electron. Period number is equal to principal value of the principal quantum number for the valency shell. Do remember this. If you want to find the period number and the group number. Okay. If you want to find the group number and the period number, group number is equal to number of valence electrons. Okay. That is for S block and P block. Okay. Yes, for S block and D block, okay, group number is equal to number of valence electrons, whereas for P block, okay, well, look here, group number is equal to, okay, is equal to what? Is equal to, can anybody tell me? Okay, group number for P block elements is equal to what? Yes, okay, it is equal to, I'll tell you what is it, don't worry. Okay, I'll find a best way for it. How to find, okay, I'll tell you. I'll give you an example and I'll make you to understand what the group number is equal to in for p block elements. Okay, now at least now if you can understand, group number is equal to number of valence electron and period number is equal to the value of the principal quantum number for the valency shell, Okay, now let us write the electronic configuration of that element with atomic number 79. Shall we write it? Come on. Okay, start with 1s, 1s2, 2s2, then after 1s, 2s, after 2s, 2p, 3s, okay, 2p6, 3s2, then 3p, okay, 6, 4s2, correct, okay, then 3d, okay, 10, okay, I'll write it here, 3d 10, okay, after 3d, okay, 4p6, after 4p, 5s2, okay, after 5s, yeah, come on, 4d 10, okay, then 5p6, okay, and then 6s2, is that correct? After 6s, okay, 4f14, but before that please count, okay, the total number of electrons here. It is 10, 20, 30, okay, 40, 50, okay, 56 plus 14 is 70, but we should get how much? 79. So we have finished 4f14. After 4f14, okay, yes, we'll have, yeah, 5d9, so that the, okay, the electronic configuration comes out to be 79, isn't it? Okay, isn't it correct? So now just check the number of electrons: 10, 20, 30, okay, 40, yes, 40, 50, okay, isn't it? 50 plus 14 is 50 plus 40, 56 plus 14 is 70, 70 plus 9 is 79. Okay, that's correct. Now, okay, look at the valency shell configuration. You should observe the valence configuration. Well, okay, the last electron is going to which group? The last electron is going to d orbital. But observe the valence configuration. Okay, what is the valence configuration? It is 6s2. Okay, so what is the value of n? What is the value of n for this orbital? The value of n is equal to 2. Okay, so it belongs to, okay, if the value of n is 2, then it belongs to which period? Yes, it belongs to second period, correct? If the value of n is 2, okay, I'm sorry, the value of the valency shell, okay, the value of n for the valency shell is 6. That means the, okay, element belongs to the sixth period. Okay, the value of n for the valency shell is sixth period. And what is the electronic configuration? Okay, for the valency shell it is 6s2. Okay, you can just check it out with the periodic table. Okay, you can directly get the answer. Look at the periodic table here. Okay, where is the element with atomic number 79? Yes, see, we got it. Okay, it is nothing but what? Gold, correct? 79. So I told you that the element belongs to which period? It belongs to sixth period. Okay, and it belongs to which group? It belongs to, okay, what you are supposed to do is, okay, it belongs to which group? It belongs to 11th group. Gold, the atomic number of gold is 79. Okay, yeah, 79. It belongs to sixth period and which group? 11th group. Am I correct? Yeah, so we got the answer. So what is the answer for it? Yes, okay. So I told you it belongs to sixth period, yes, and 11th group. So the answer is option B. Okay, gold with atomic number okay, 79. The valency shell electronic configuration is 6s2. 6s2. Understood? So the principal quantum number for the valency shell is 6. Hence, gold belongs to 6th period. And which group? 11th group. It belongs to 11th group. Okay, that's correct. Exactly. Now, yes, next question. Yes, we shall go with the next question. What is it? Okay, which of the following have the same number of electrons in the outermost shell? Okay, which of the following should have the same number of electrons in the outermost shell? That means if the elements have the same number of electrons in the outermost shell, okay, if the elements have same number of electrons in outermost shell, then those elements belong to the same group. Note this point. Okay, yes, if the elements have same number of electrons in the outermost shell, then the elements belong to the same group. See, if the elements belong to the same group, okay, if the elements belong to the same group, the successive atomic number will repeat at an interval of 2, 8, 8, 18, 18 and 32. Okay, the successive, okay, atomic number will repeat at an interval of how much? 2, 8, 8, 18, 18 and 32. Are you getting my point? Okay, so if the elements have same number of electrons in the outermost shell, then the elements belong to the same group, and if the elements belong to the same group, then the successive atomic number will vary at an interval of 2, 8, 8, 18, 18 and 32. Now, if you consider these elements, just consider these elements, okay. So atomic number is 30 and 48. 30, 48. What is the difference between 30 and 48? Okay, it's 18. Correct. Next, 48 and 80. What is the difference between 48 and 80? It's 32. So from here to here it is 18, and from here to here it is 32. Is that correct? So are they okay? Are the successive atomic numbers okay varying in this interval 18 and 32? Yeah. Let us check out with the other electronic configurations. Look here. What is the difference between this to this? It's 1. It's from this to this, it's 1. No, that means these elements do not belong to the same period. Okay, sorry, same group. They do not belong to the same group. Why? Because the successive atomic numbers should vary in this interval. But here the successive atomic numbers are varying in the interval of 1. Therefore, this cannot be the answer. Okay, how about this elements with atomic number 10, 30 and 50? What is the difference between this to this? It's 10. From this to this, it's 20. No, okay, they are not varying. The successive atomic numbers are not varying in this interval. Therefore, they do not belong to the same period. How about this elements with atomic number 10, 18 and 26? What is the difference between 10 to 18? It's 8. What is the difference between 18 to 26? It's 8. Okay, 10 to 18 it's also 8. Okay, 18 to 26 is also 8, but here also they do not belong to the same period, sorry, same group. Why? I'll tell you. If the element is atomic number 10, then it's obviously it is what? Neon. Okay, which is the next element after neon? It's argon, no doubt. It's 18. 10 plus 8 is 18. Which is the element after argon? Okay, helium, neon, argon, krypton. What is the atomic number of krypton? It's 36. What is the difference between argon to krypton? It is 18. But here the successive difference is 8. Therefore, do these elements belong to the same group? No, they do not belong to the same group. That means which sort of element, which set of elements belong to the same group? Yes, it's option A. Why do they belong to the same group? Because the successive atomic numbers will vary at an interval of 18 and 32. Okay, as expected. 2, 8, 8, 18, 18 and 32. 2, 8, 8, 18, 18 and 32. Here also you might ask the question. Here also the successive atomic numbers are varying at this interval 8 and 8. But if you take up the first element with atomic number 10, it is nothing but neon. Okay, the next element is going to be argon, the next element is going to be krypton. Okay, from neon to argon it's 8, no doubt in it. But from argon to krypton it is 18. Therefore, if the atomic number is 10, then the next element will repeat at an interval of 8, and the next element should repeat at an interval of 18. But here the next element is repeating at an interval of 8. Therefore, they do not belong to the same group. So, okay, which set of elements belong to the same group? It is 30, 48 and 80. 30, 48 and 80. So what is the correct option for this? Yeah, it is option A. Hope you have understood. Yes, exactly. Okay, next question. Yes, next question. Come on, we have to match the columns 1, 2 and 3 and mark the appropriate choice. Okay, match the columns 1, 2 and 3 and mark the appropriate choice. So we have in column 1 we have bromine, gold, mercury and iodine. Okay, and in column 2 we have noble metal. It's not noble gas, it's a noble metal. Okay, crystalline non-metal, crystalline non-metal, okay, liquid non-metal and liquid metal. See, in the previous video I have told you which is a liquid metal. There is only one metal which is in liquid state. All other metals are in solid state. Only the mercury is a liquid metal. Liquid metal at room temperature. Bromine, I have told you that it is the only, okay, liquid. It's the only liquid non-metal at room temperature. Non-metal at room temperature. And platinum, gold, silver. See, these three elements are called as noble metals. Noble metals. Okay, platinum, gold and silver are called as what? Noble metals. So at least this is enough to answer this question, I guess. Okay, so bromine, I told you bromine is liquid non-metal at room temperature. So bromine is liquid non-metal. So A is matched to 3. Yes, correct. And bromine is, okay, what is it? Okay, yeah, we know what is the color of bromine. Okay, I'll tell you, wait. Gold. Okay, what is gold? Gold is a noble metal. Therefore, gold, B is matched to 1. Mercury is, yeah, liquid non-metal. Sorry, liquid metal, I have told you. And iodine, okay, the only option we are left with, it's a crystalline non-metal. It's a crystalline non-metal. Okay, usually non-metals are gases. Non-metals are gases. It is only iodine which exists in crystalline solid state. It is only which exists in, okay, crystalline solid state, whereas all other non-metals are gases. It is only iodine which exists in crystalline solid state. So therefore, okay, D is matched to 2. Okay, so we have matched, okay, column 1 with column 2. And we have to match these two with column 3. Okay, these two with column 3. Now amalgam, what do you mean by amalgam? Okay, by the way, what is amalgam? Just try to understand. Amalgam is nothing but mixture of any metal with mercury. Mixture of any metal with mercury is called as amalgam. What do you mean by zinc amalgam? Mixture of zinc and mercury. What is sodium amalgam? Mixture of sodium and mercury. Mixture of any metal with mercury is called as amalgam. Therefore, amalgam, so can I match it with, okay, yes, C, okay, 3 is matched to P, okay. What is this 4s2? Okay, I'll just check out. It is 4s2, 4p5, 4s2, 4p5, and okay, look here, violet. See, it is iodine is the, I told you iodine, it exists only in crystalline solid state. And what is the color of this iodine? They are violet crystals. Violet crystals. Iodine is a violet crystal. So that means, okay, iodine 4 is matched to, yes. and 4s2 4p5. 4s2 4p5 is the general outer electronic configuration of halogens. 4s2 4p5 is the general outer electronic configuration of halogens. Which is the halogen other than iodine here? Bromine, correct? Bromine is the halogen, okay, whose outer electronic configuration is 4s2 4p5. That means 1 is matched to Q. Okay, so what are the other things? Okay, gold, yeah, it's a transition metal. Yes, amalgam, mercury, bromine, halogen, that is, okay, it is matched to Q, and iodine is violet. So can just think of it. Okay, what are the, yeah, A. Okay, if you go for A is matched to 3 and 3 is matched to P. Yeah, 3 is matched to P. Okay, correct. So we are getting this option. Just check out gold, B. Gold is matched to what? Okay, 1. Yes, gold is matched to 1 and 1 is matched to, okay, where did we match 1? Yeah, 1 is matched to R. Okay, it's a transition metal. 1 is matched to R. No. Okay. Okay, 1 minute. 3. Bromine is matched to 3 and 3 is matched to what? Okay, well, sorry. Okay, 3 is matched to Q. 3 is matched to Q. I told you bromine is an halogen and its outer electronic configuration is 4s2 4p5. Therefore, this is not the correct answer. 3 is matched to Q. Now, look at first one. Okay, next gold. Gold is matched to 1. Okay, and 1 is matched to R. Yeah, that's correct. 1 is matched to R. Next, fourth, mercury. Mercury is matched to 4. And fourth is matched to what? Amalgam. P. Yes, fourth is matched to P. Yes, next, fifth one, iodine. Iodine is matched to 2. It's a crystalline non-metal. And 2 is matched to what? Violet. Yes. 2 is matched to, yes. So what's the correct answer for this then? It is option A. Okay, it's a bit complex. You have to be very careful in answering this question. So if I take bromine, bromine is a liquid non-metal and it's an halogen. Okay, so 3Q, correct? Next, gold. Gold is a, okay, noble metal and it's a transition metal. That means 1 to R, 1 to R. Clear? Next, mercury. Mercury is a liquid metal and it is used as an amalgam. So that means 4 to P, correct? Okay. Then iodine. Iodine is a crystalline non-metal and it is violet in color. That means 2 to yes, 2 to yes. That's exactly correct. So what's the correct answer? It is option A. I hope you understood. Yes, exactly. Okay. Next question. Let us go a bit faster. Yes. The next question is like this. It is from this year, Karnataka CET 2020. Okay. Very simple question. The last element of the P block, okay, the last element of the P block, okay, in the sixth period is represented by the outermost electronic configuration. Okay, the last element, I think we have already solved this question, okay, but still it has been repeated in Karnataka CET 2020. Okay, the last element of the P block is in the sixth period. The last element of the P block means, okay, so last element P block has 3 groups, 1, 2, 13, 14th, 15th, okay, 16th and 17th and also 18th group. So the last element comes here and is telling, okay, it belongs to the 6th period. Last element belongs to 18th group. Okay, last element belongs to 18th group. 18th group means noble gas family. Noble gas family, is it correct? Okay, the last element of the P block belongs to what? 18th group. 18th group means noble gas family. And for noble gas family, what is the general outer electronic configuration? It is Ns2Np6. For noble gases, the general outer electronic configuration is Ns2Np6. And it's telling 6th period. I have told you so many times. What does the period number indicates? Yeah, period number, okay, indicates what? The value of the principal quantum number of the valency shell. Okay, the value of the principal quantum number of the valency shell. Therefore, for 6th period, okay, period, n value will be equal to 6. For what? For the valency shell, the n value is going to be 6. So for noble gases, the valency shell configuration is ns2 np6. And what is the value of n for this given element? It is 6. Hence it is 6s2 6p6. 6s2 6p6. Look at here, look at the question. The last element of the p block in the 6th period is represented by the outermost electronic configuration. What will be the outermost electronic configuration for the last element of the p block which is present in the 6th period? It is obviously 6s2 6p6. Hence the correct answer is going to be option C. Okay, yes. Next question, students. Let us go faster. Okay, well, what is the next question? The species they have given, it is All India Pre-Medical Test 2015, very recent question. Okay, the question says the species argon K plus Ca2 plus contain the same number of electrons. Okay, what if they contain the same number of electrons? They are called as isoelectronic species, isn't it? Okay, argon K plus Ca2 plus contain the same number of electrons. That means they are isoelectronic with each other. In which order their radii will increase? In which order their radii will increase? So we have argon, okay, K plus and Ca2 plus. Haven't I told you that? Okay, if I talk about the atomic radii or ionic radii, okay, the anionic radii, okay, will be larger than a neutral atom, and a neutral atom will be bigger than what? A cationic size. Cationic radii will be bigger than cation. An anion is always bigger than the neutral atom, and a neutral atom is always bigger than a cation. Okay, so we have a neutral atom and we have cations. So that means obviously according to this rule, the size of neutral atom should be more than the size of this cation, correct? So then can I say that argon is bigger than K plus and Ca2 plus? Yes, of course, because it's a neutral atom. Neutral atoms are bigger than what? Cations. So argon is bigger. Argon is bigger when compared to K plus and Ca2 plus. But out of these two cations, which one is bigger and which one is smaller? I have told you among cationic radii, okay, higher the positive charge, lesser will be the size, isn't it? Higher the positive charge, lesser will be the size. This has +2 charge and this has plus charge. +2 charge and plus charge. Okay, so here the positive charge is more, here the positive charge is less. More the positive charge, lesser will be the size. Then that means to say K plus ion is bigger than Ca2 plus. And okay, now and argon is bigger than what? These cations. Argon is bigger than cations, and among cations, higher the positive charge, lesser will be the ionic size. So therefore K plus ion is bigger than Ca2 plus. So what is the correct order here? Yeah, we have option B. Argon is bigger than K plus is bigger than Ca2 plus. So neutral atoms are bigger than the cations, and among cations, okay, higher the positive charge, least will be the atomic or ionic size. Okay, so answer for this question is going to be, okay, option B. Yes, excellent. Okay, next question, students. Next question. Okay, the next question says the number of d electrons in Fe2 plus is not equal to the number of electrons in which of the following? Okay, the question is the number of d electrons in Fe2 plus is not equal to the number of electrons in which of the following? Okay, let us write the electronic configuration of iron. Okay, atomic number of iron, it is given how much? It is 26. Electronic configuration is going to be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6, but the given iron is in +2 oxidation state. Okay, that means we need to remove the two outermost electrons. Okay, so now the total number of electrons is going to be 24. Okay, yes. Okay, then so the question is not so appropriate. Again, it's in All India Pre-Medical Test. Okay, the number of d electrons in Fe2 plus is not equal to the number of electrons in which of the following? Okay, that means p electrons in chlorine, d electrons in iron, okay, p electrons in neon, s electrons in magnesium. Let us check. Okay, so chlorine, okay, atomic number, it is given 17. What's its electronic configuration? Okay, how many number of d electrons in Fe2 plus? It's 6. Number of d electrons in Fe2 plus is 6. Is that correct? Yeah. P electrons in chlorine, 1s2, 2s2, 2p6, 3s2, 3p5. Okay, this is what the electronic configuration is, chlorine. Okay, now how many number of p electrons in chlorine? 6 plus 5, total 11. How many number of d electrons in Fe2 plus? 6. Correct. Next, if I go with iron, d electrons of iron, Fe, already we have written, it is 1s2, 2s2, okay, 2p6, 3s2, 3p6, okay, 4s2 and 3d6. Okay, how many number of d electrons in Fe2 plus? 6. How many number of d electrons in Fe? It is also 6. So the number of d electrons in Fe2 plus is equal to number of d electrons in Fe, equal. If I go with neon, atomic number of neon is 10. What's its electronic configuration? 1s2, 2s2, 2p6. P electrons of neon. Okay, p electrons. How many p electrons of neon? 6. D electrons on Fe2 plus 6. So they are equal. Correct? Okay. Next, s electrons in magnesium. Atomic number of magnesium is 12. What is its electronic configuration? 1s2, 2s2, 2p6, 3s2. Okay, total number of s electrons in magnesium 2, 4, 6. Total it is how much? 6. Look at here. Okay. Total number of d electrons in Fe2 plus is equal to the number of d electrons in Fe, the number of p electrons in neon, and it is equal to the number of s electrons in magnesium. But okay, the total number of d electrons in Fe2 plus is not equal to the number of p electrons in chlorine. Number of p electrons in chlorine. How many total number of p electrons in chlorine? 11. What is the total number of d electrons in Fe2 plus? It is 6. They are not equal. Hence, what is the correct answer? It is option A. Option A. Yes. Okay. Okay. Next question, students. Okay. Yes. Next question, students. Okay. Yeah. This we have finished. What is it? Where we were? Yeah. Okay. Which question? Yeah. We have finished this 73rd question. We have got 4 more questions. Let us make it as quick as possible. Okay. Yes. What is the next question? Okay. Which of the following options the order of arrangement does not agree with the arrangement of the property indicated against it? Okay, which of the following? It's a neat question from 2016. Okay, please emphasize on previous year question papers. Okay, so in which of the following options the order of arrangement does not agree with the variation of the property indicated against it? Okay, so we have Al3 plus, Mg2 plus, Na plus and F minus. Okay, yes. So we know, students, okay, anions are bigger than cations. Yes, true. And also among cations, higher the positive charge, smaller is the size. Okay, that means this property is correct. Correct? Yeah. Next, okay, we have boron, carbon, nitrogen, oxygen. Increasing first ionization enthalpy. We have boron, carbon, nitrogen, oxygen. No doubt along the period, ionization enthalpy should increase. Correct? From boron to carbon, it increases. From carbon to nitrogen, it increases. But from nitrogen to oxygen, it should decrease. Isn't it? We have learned this. We have learned about ionization enthalpy. From boron to carbon, it increases. From carbon to nitrogen, it increases. But from nitrogen to oxygen, it should decrease. Okay, I have told you. Where does the, okay, what are the exceptions for ionization enthalpy? Okay, so exceptions is from second group to, okay, 13th group. Okay, here we find exceptions where second group, okay, ionization enthalpy of second group elements is more than the ionization of enthalpy of 13th group elements. And also the other exception is 15th group and 16th group. 15th group and 16th group. The ionization enthalpy of 15th group is more than the ionization enthalpy of 16th group, which is against the rule that we have learnt. What is the rule? The ionization enthalpy should increase along the period, but it decreases from second group to 13th group, second group to 13th group, and it decreases from 15th group to 16th group. Okay, these are the exception. So but here, look here, okay, boron to carbon, it has increased, okay, carbon to nitrogen, it has increased, okay, but from nitrogen to oxygen, it should decrease. It should decrease. That means this is not in the correct order. This is not in the correct order. Okay, is it? Okay, now we have fluorine, chlorine, bromine, iodine. Actually this order is also not correct, but to certain extent we can accept. We have fluorine, chlorine, bromine, iodine. Down the group, okay, electron gain enthalpy should decrease. So that means fluorine has more electron gain enthalpy than chlorine. Chlorine has more electron gain enthalpy than bromine. Bromine has more electron gain enthalpy than iodine. But this is also wrong. What is the correct order? Strictly speaking, the exact order is chlorine should have more electron gain enthalpy than fluorine. Fluorine has more electron gain enthalpy than bromine than iodine. Strictly speaking, this is correct, but to certain extent we can accept this. To certain extent we can accept this. Okay, let us say this is correct. Okay, lithium, sodium, potassium, rubidium. Of course, down the group, metallic radii, that is atomic radii, increases, isn't it? We have lithium, sodium, potassium, rubidium, cesium and francium. So down the group, okay, metallic radii, that is nothing but atomic radii increases. So okay, rubidium is bigger than potassium, potassium is bigger than sodium, sodium is bigger than lithium. So this is also correct. So the only incorrect statement is option B. Exactly. Okay, simple. Yeah, next question. We have got 3 more questions. Let us finish off as quick as possible. Okay, students, this question is from NEET 2017. Very recent question. The element with atomic number, okay, Z equal to 114 has been discovered recently. It will belong to, okay, which of the following family or groups and electronic configuration? Look here, okay, which of the it belongs to? The element with atomic number 114. Z means 114. Z means what? Atomic number. The element has an atomic number 114. It has been discovered recently. Okay, it will belong to which of the following family or group, and what is its electronic configuration? Look here, the last element is 118. It belongs to which group? 18th group. The next element is 117. It belongs to 17th group. The next element is 116, 16th group. Next, okay, 115, 15th group. The next element is 114, 14th group. 14th group means which family? Carbon family. Okay, carbon family. What is the general outer electronic configuration of carbon family? It is Ns2 Np2. The general outer electronic configuration of carbon family is Ns2 Np2, and okay, 118, the last element is in 6th period. These elements are in 6th period. Okay, for 6th period, N value is equal to how much? For 6th period, N value is equal to 6. That means, okay, the element 114 will have an outer electronic configuration of 6s2, 6p2. Okay, the outer electronic configuration is going to be 6s2, 6p2. Therefore, the element 114, it belongs to carbon family. And what will be its general outer electronic configuration? It is, sorry, it belongs to 7th period. Okay, sorry. Yeah, this 118, it belongs to 7th period. 7th period means 7s2, 7p2. Okay, yes. Okay, so the element belongs to carbon family, no doubt in it. And what is its general outer electronic configuration? 7s2, 7p2. Why it is 7s2, 7p2? Because it belongs to 7th period. For 7th period, N value is 7. Hence, the exact answer is option A. Correct. Next. Okay, students, 2 more questions. Yeah. Okay, 2019, NEET 2019, very recent question. Okay, they are talking about increasing order of first ionization enthalpy. Okay, very simple question. Okay, very simple question, isn't it? The increasing order of first ionization enthalpy, they have given lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and also neon. Okay, what should happen to the ionization enthalpy along the period? Ionization enthalpy increases along the period, isn't it? So from lithium to beryllium, it increases. But be careful, from beryllium to boron, it decreases. Okay, exceptions of ionization enthalpy. Then from boron to carbon, increases. Carbon to nitrogen, increases. From nitrogen to oxygen, it decreases. Again an exception. Okay, second group, 13th group. 15th group, 16th group. Okay, from oxygen to fluorine, increases. Fluorine to neon, increases. So this is the exact order. So where do you find it? Okay, where do you find this? Yes, yeah, I think it's where do we come across? Neon is more than, we don't have any options of such kind. Neon is more than fluorine. Yeah, here we have. Here also we don't have. Okay, I can take this as answer. Lithium, okay, less than beryllium, less than boron. Okay, less than boron, less than beryllium, carbon, nitrogen, oxygen, fluorine, neon. Okay, we have got two answers. We can accept this as well as this. In this option, okay, in this option, they have given this exception. In this option, they have given this option. Okay, yes, both the options can be proper because both the exceptions are correct. So boron has less ionization enthalpy than beryllium, correct? Okay, nitrogen has more ionization enthalpy than oxygen. So both the options are correct. Option C as well as option D. Option D. Okay, is that simple? Yes, exactly. Next question, the last question. Okay, so students, match the following. Okay, match the following. Look at here. Yes. Okay, you should know this. Un, nil, unium. Un means what? Un means, okay, 1. Nil means 0. Un, okay, means again 1. 1, 0, 1. The element is 1, 0, 1. Next, un, nil, trium. Un means 1. Nil means 0. Trium, tri means 3. Okay, next, un, nil, hexium. Un, 1. Nil, okay, 0, hex 6. Next, unium. Okay, un means 1, un and 1, 111. Correct? Okay, yes. So we have to match the following. Reason, very recent question, NEET 2020. Un, nil, unium. Okay, remember this table? Okay, nil, un, bi, tri, quad, okay, pent, hex, hept, or it is also called as sept, okay, oct, yes, non or n, and dec. Okay, we don't have dec. Okay, at least this n. Nil means 0, un means 1, bi 2, tri 3, quad 4, pent 5, hex 6, hept 7, okay, oct 8, n means 9. So un 1, nil 0, un 1. So 1 0 1, un 1, nil 0, tri 3. Okay, next un 1, nil 0, hex 6, 106. Next un, that means 1 1 1. Okay, so 111. So we should match these elements. Okay, we should match these elements with the, okay, proper name of the corresponding element. Okay, so that means we have to refer back to the periodic table. Okay, we should refer back to this periodic table. Yeah, we'll go back to the periodic table. So which are those elements, by the way? So we have 101, 103, 106 and 111. Okay, the last question, let us see. Okay, yeah, okay, 101, 101, where is it? Okay, where do you find the element with atomic number 101? Yeah, it is Mendelevium. 101 is Mendelevium. Okay, 103. Okay, yes, 103 is Laurentium. 103 is Laurentium. Okay, 106, yeah, Seaborgium, okay, and 111, 111, okay, 111 means, okay, Roentgenium, okay. So 101 means Mendelevium, 103 is Laurentium, 106 is Seaborgium, and 111 is Roentgenium. Okay, correct? Yeah. So let us match. Okay, the last question. Okay, it's a very recent question, NEET 2020. Okay. Okay. Yes, where is the last question? Yes. So we have this. Okay, unylium means 101, 103, 106, 111. Okay, I told you 101 is Mendelevium. Okay, 103 is Laurentium. Okay, same 106 Seaborgium, and 111 it is nothing but, okay, so it is Dramastadium. Okay, so A is matched to 1. Okay, which one of the following is correct? All of them are correct, isn't it? Okay, probably, okay, the question has to be which of the following is incorrect. Yes, okay, look at here, 111 is Roentgenium, they have given 111 as Dramstadium, okay, but it is incorrect. It is incorrect. So D is matched to 4. This is incorrect. The question has to be incorrect. Okay, there is a printing error. C is matched to 3. Yes, unyl hexium is Seaborgium. That is correct. 106 is Seaborgium. Okay, A is matched to 1. Okay, unylium is Mendelevium. Yes, it is correct. Okay, B is matched to 2. Okay, so that means 103 is Laurentium. Yeah, 103 is Laurentium. The only option which is incorrect is option D. Option D. Okay, so the question has to be which one of the following is incorrect. There is a printing error, it is. Okay, which of the following is incorrect? It is option D. Okay, option D. D means, okay, 111, it should be Roentgenium, but it has been matched in an incorrect way. Okay, yes. So with this, students, I'll wind off solving the MCQs on the 3rd chapter. In the next subsequent videos, we will go with the next chapter. Thank you.